Okay, we ask what transformations are needed to sketch the vector y, or the function y equals 1/2 x squared minus 6x plus 4, starting with your basic y equals x squared function. Well, I give you a hint. I say the vertex is at 6, -14. Now let's see how I found that. Okay, so vertex, the quadratic formula, you got a equals 1/2, b equals -6, c equals 4. The solutions, the zeros, are at x equals negative of -6 plus or minus the square root of -6 quantity squared minus 4 times 1/2 times 4 divided by 2 times 1/2. Let's see if I was telling the truth when I said the vertex was at 6, -14. Okay, so let's see. -6 is 6, and you divide that by 2 times 1/2. This divided by this is this, and that is where your vertex is. Okay? And then you have plus or minus the square root of what? Well, that's 36, that's minus 8, so that's 28 over 1, which is 6 over 1 plus or minus 2 square root of 7, or just plain old 6 plus or minus 2 square root of 7. So if you're trying to do a picture of this graph, you go to 6 here, and you're going to have a 0 here and a 0 out here somewhere. And your graph is going to open. How does your graph open? Well, let's see. So somehow, okay, let me back up a minute. Okay, so your vertex is on the line x equals 6. Well, so the y-coordinate of your vertex is what? Y equals, well, let's plug in 6 for x, right? Because if x is 6, well, the equation tells you what y is. So that's going to be 1/2 times 6 squared minus 6 times 6 plus 4. And 6 squared is 36, half of that is 18. Then it's minus 36 plus 4. And that's, let's see, -18 plus 4 is -14. And that's what I said it was. Okay, so the vertex is down here at, if that's 6, well, -14 is not quite this far down, but we'll just draw it as if it is. So, yeah, here's our graph. Okay? Not a really particularly well-drawn graph. Now the question is, how does that graph come about by sequence of transformations? Well, you start with the x squared graph. So here's your x squared graph. And we know that our transformed function is of the form y equals a times x minus h squared plus k. Because we're going to do a vertical stretch, a horizontal, and a vertical shift. So you have y equals f of, well, y equals a f of x minus h plus k. This is a general form of any function that's transformed by shifting h units in the x direction, k units in the vertical or y direction, and with the vertical stretch of a. Okay, well, we know that we do the vertical stretch first. It's kind of like you do multiplication before you do addition. The vertical stretch is a number that multiplies something else. So you have to do the multiplication before you do any addition or subtraction. Okay, well, and this y is going to equal 1/2 x squared, let's see, minus 6x plus 4. You could expand this square. You'd get x squared minus 2xh plus h squared. What do you have to do to get a 1/2 x squared? We're getting an x squared out of expanding this, and it's multiplied by a. So it follows that a is 1/2. So we're going to vertically stretch the y equals x squared graph by factor 1/2. We're going to take each point of this graph, and I'll just not labeling any points or coordinates or anything, but I'm going to take each one of these coordinates and move it twice as close to the x-axis. And then I'm going to draw, and of course the origin's going to stay where it is, then I'll draw my parabola through that. So this is my y equals 1/2 x squared parabola. Now what do? Well, I just shift the thing over 6 units and down 14 units, and here I am. So let's grab a couple other colors here. Let's see, I think the better colors are over here. I've already used purple. So I shift every point 6 units. So I shift vertex 6 units in the x direction, shift this point 6 units in the x direction, shift this point 6 units in the x direction, and so forth. Now I'd shift each of these points. But it's clear I get, it's a little hard to draw backwards. Okay, I get this. Then I shift each of these points down 14 units, and I get points on this curve. As I say, it's not particularly well drawn. For example, it's supposed to go through the y-axis at y equals 4. If x equals 0, you can see that y is going to be 4, and it doesn't look like I took that into account. I didn't take that into account when I drew it. Okay? But what we've seen then is, by the quadratic formula, we know where the vertex is going to be. So the vertex, we know, shifts 6 units over, 14 units down. Then a little reasoning here. If it's a times x minus h squared plus k, then a has to equal 1/2. So, again, starting with y equals x squared, we do the vertical stretch by factor 1/2. Bring every point twice as close to the x-axis. Then we do our horizontal shift. Now we could have done the vertical shift, then the horizontal shift, but the way I've drawn it, we did the horizontal shift, then the vertical shift. Horizontal shift, 6 units. Every point moves 6 units to the right. Vertical shift, negative 14 units. Every point moves 14 units downward.